This is a presentation of Welcome Molalla, where we bring you fun and informative videos from within our community. In today's episode, Bob O'Black, rock hound enthusiast and longtime Molalla resident, will give us a tour of the Molalla River corridor and discuss its geology.
Good morning, my name is Bob O'Black. I'm a resident of Dickey Prairie, which is just a little small community just outside of Molalla, about 3 miles east of Molalla. And today I'm standing on the Fire Park Bridge to discuss some of the geologic points of interest that we can see up the Molalla River corridor. This year marks the first anniversary of the Molalla River designated as a wild and scenic river. It's a national designation signed into law by our current administration. What we're looking at is a lahar from the viewpoint of the Fire Park Bridge. So let's take a closer look at this lahar. You can see the large boulders and small gravelly mud that took place. When this lahar happened, it probably took place several million years ago when the ancient Western Cascade Range was being developed. This Cascade Range started about 40 million years ago. So as it was erupting and snow might have been on the volcanic activity, erupted and molten lava and melted the ice and water and mud and logs came down an ancient Molalla River channel. As a matter of fact, back in 1980, almost 40 years ago, when Mount St. Helens erupted, it's an excellent example of looking at the Toutle River, what happened to it during the eruption of Mount St. Helens. And we'll have some evidence of that in our video showing what a lahar in present day looks like. And just what we're seeing behind us here, this lahar several million years ago now is solidified into a solid rock formation and is a great evidence of what took place during the Mount St. Helens eruption.
So this is a great example of what's inside a pyroclastic flow. We've got small, rounded, jagged rocks, mud in between, huge boulders up here, another big boulder over here, and all of this mixed together was probably decomposed wood and logs and other things in this lahar, which was over 40 feet thick as it went down an ancient Molalla River channel millions of years ago, now frozen in time.
From this viewpoint off the bridge, you can see the separation of the lahar, which is right above the sandstone level. So there's the river, there's a layer of sandstone about 15 feet, and then above that sandstone is the lahar frozen in place or solidified in place. And as a good example of it, how high that lahar was. So from this vantage point, you can see the depth of the lahar must have been 20, 30, 40 feet high in depth as it went down this ancient river channel. The Toutle River lahar back in 1980 when Mount St. Helens erupted was upwards of 30 or 40 feet. As we leave the bridge here, we'll actually be going upriver, and we'll be witnessing actually two different distinct time periods in geological history. The first being when the ancestral Western Cascades were being built, which is about 40 million years ago. And these are the oldest rocks that we see in the river. So I want to point out here on the Glen Haven Bridge, which is the beginning of the Molalla River corridor that we're standing on here, is the river going upriver or south of me is a straight shot and goes under the bridge and down to a place where it turns. This is an example of a fault, an earthquake fault, if you will, ancient one, that made the river go down the fault direction. So there'll be many sections as we drive up river that you'll see where the river runs straight and it's confined in these faults from the ancient earthquake faults. So this is a good example that we can see easily how the river is confined where the fault is. So we've traveled upriver to a little pull-off called Party Rock, and when you look at the map you can see where we're at upriver, several miles up from the Glenhaven Bridge. And we've traveled back in time now to view the two different ages of the rocks that are in this river. As I mentioned earlier, the ancient Western Cascades were being built about 40 million years ago when they first started erupting into this volcanic chain, and the Molalla River headwaters are part of this Western Cascade range. So many of the rocks in this river are pretty old, 40 million years and less, and are coming from that ancient Western Cascade range. And from this viewpoint, we'll see the younger rocks, and actually there's a hillside here that we're looking at, and this is a hillside that this rock actually came from the Oregon-Idaho border. Now, it didn't tumble down from the Oregon-Idaho border. It actually flowed like a river of lava that erupted from the Oregon-Idaho border. And they've actually identified the time when this took place as about 15.5 million years ago. So as that rock from that cliff erodes into rounded river rock that we see here in the river, those are the two different ages of the river rocks. The older Western Cascades, 40 million years and a little bit younger, and then the rocks from this lava that came from Oregon, Idaho about 15.5 million years ago. So as we're walking along on the river, there are actually two different ages of those rocks. Now let me talk a little bit more about this embankment here that we're looking at. The embankment actually is right next to Shotgun Creek. So when you come up here at some point in time and want to go to Shotgun Falls, to the right of that embankment is Shotgun Creek, and that's where Shotgun Falls is located. So if you want to take a hike up there, we'll put pictures of Shotgun Falls in this video so you can see what the 30-foot waterfall looks like. So let me talk a little bit more about this escarpment here, this lava cliffside. So as I mentioned, it came from the Oregon-Idaho border as molten lava, over 100 feet thick, and started cooling, stayed in place as we see it here. And so the pattern of the rocks that we're looking at are actually cooling patterns formed in different sections based on the cooling rate of that molten lava turning into basalt. So the lower portion of that face that we're looking at has a name called the colonnade, and that name comes from the Greek building structures that the Greeks identified the different sections of their buildings. So the lower part is called a colonnade. If you look at a Greek structure, the columns and that are holding up the roof is called a colonnade, and then the top part of the roof of a Greek building is called a entablature. So the upper part is called the entablature. Now you might think that, well, that was maybe two different lava flows, and actually it isn't. That's all one lava flow, several hundred feet thick. Again, came from Oregon-Idaho border. Just kind of let your mind wrap around it. We're in Molalla. The Oregon-Idaho border is several hundred miles away from here. So that lava flowed hundreds of feet thick all the way from that distance. And then as we see it here, and actually multiple flows took place over 15.5 million years ago, hundreds of feet thick throughout this canyon in the Molalla River. They've actually identified this flow. There's names of all the different flows that took place over 2 or 3 million years coming out of the Oregon-Idaho border, and this name on this one is called the Wampum Flow, or the Frenchman Springs Flow. So the upper part of the escarpment, several thousand years ago, maybe even millions of years ago, the river was roaring through here, and it scoured that face of that lava, actually basalt, and is deposited in the river. So there are big boulders, I mean 30-foot big boulders laying here in the river. And these are actually part of that lava that came down from the Oregon-Idaho border that are now deposited and created party rock here in the Molalla River. This is the colonnade of lava flow. The upper part has been eroded away, so we don't see it. And you notice how thick comparison to the other lava, so it's usually about 1/4 of the flow. So what we're seeing is only 25% of that lava flow. The rest of the top part has been eroded away by the river. So this was, again, a huge wall at one time. Well, this is our second stop on our tour of the Molalla River, and we're at a location called the Rosette, sometimes referred as the Molalla Eye, and it's a unique pattern. And again, when I talked about the cooling of lava, when we were at the earlier location, we saw a colonnade and how they were perpendicular to the cooling surface or the ground level at that location earlier. Here, we're witnessing a cooling pattern that is more radial in shape, and or fan shaped, if you will. And again, this cooling pattern is a direct result of the cooling of the lava, which is perpendicular to the surface in which it was laid into. So in this case, the lava filled in a valley and solidified in this shape. The cooling progress really caused shrinking, and in a pattern that is horizontal to the surface, and eventually this river raced through here and wore away part of the lava, exposing the radial fan pattern. And as this lava came through and entered a valley, the cooling was again perpendicular to the valley floor, if you will, or the valley sides, and created this fan-like pattern. And when the river raced through here, it exposed the shape that we see today. Really a beautiful example of the beauty on this river. We're about 100 yards up from the Rosette, which is really a part of the narrows that we call here on the Molalla River, where the river narrows down to a very narrow part of its flow. It's very deep here, several, maybe 20, 30, 40 feet deep in the narrows. And the river has cut itself through another one of these lava flows from the Oregon-Idaho border on our left-hand side of the river as we're looking at it here. Huge amount of lava. This is probably 300-400 feet high. It might be one or two flows, one on top of each other. Again, this lava came down molten, just extremely hot, flowed like a river coming down here. So over on our left here of the river was an ancient river valley where the lava came down, and it's now solidified in place, created this basalt cliff, and it's constricted the Molalla River into a very narrow channel, hence the term narrows. And is another example of these huge Columbia River basalt flows that took place about 15.5 million years ago. So again, the rocks in the river that we see, many of them come from this lava that flowed down these ancient river channels. And many times they probably blocked the Molalla River and created dams behind it. And then the river eventually worked its way through. And in this case, it worked its way through at a very narrow channel, creating a beautiful spot here on the river. What a wonderful place we have in our own backyard. All right, so we're just up from the Narrows now, right where the Narrows actually begins from downriver, and we're seeing this hillside again as an example of this Columbia River basalt flow, the Frenchman leg of it, if you will, which was part of the Wampum flow. And this probably is two different flows that took place because of the height that's here. And this is where the river cuts through and makes the narrows. Just a beautiful, beautiful sight. And as we go and pan upriver, we're seeing where the river kind of goes straight again. This is another example of the river kind of being confined within a fault zone of the earth crack, the slip fault. And the river tends to follow those faults, and then it hits this Columbia River Basalt Flow and tries to make its way through and cut its way through the lava that was poured out from the Oregon-Idaho border. Again, it's just an amazing sight to witness the power of the river carving itself through this basalt. All right, we're standing on a bridge about a mile up from the Narrows, the Rosette, if you will, upriver. And it's a good example, again, of some of the huge amounts of lava that flowed from the Oregon-Idaho border here. And the river taking an immediate left turn because it ran into this lava. And it's just, you can see the enormity of the size of this cliff face. Is probably 200-300 feet high. And it's one flow of lava from the Oregon-Idaho border. It just, my mind just can't wrap around the amount of material and the thickness of the material that flowed from the Oregon-Idaho border and filled up the old ancient river channels here on the Molalla River. Again, an excellent example of what we have here in our backyard. Right, so we're just near the Narrows here, and the opposite side of the road showing again another flow of the Columbia River Basalt Flow. And I wanted to point out that this flow came over an area of vegetation. And imagine this again is extremely hot lava. It's liquid lava. It's not this hard basalt that we're seeing. It was before it cooled, and it came over some area of vegetation. And this material here it almost looks like coal. It's been fried by the hot lava that went over top of it. And there's a little seam here. And then below here is sandstone. So this river had deposited some soil, if you will, and then all of a sudden, 15.5 million years ago, this lava come pouring over top of the sandstone. There was some vegetation and has created, if you will, a little bit of a coal seam. Just burnt the dirt and the vegetation that was in here. It's a great example of the heat that basically pancaked this bottom of the valley when it came down. So we're coming to the end of part one of our geologic feature on the Molalla River. I wanted to end here showing our Columbia River Basalt Flow because there's much more to talk about the Columbia River Basalt Flow than the Molalla area. So we'll have another part two talking about the Columbia River Basalt Flow and some of the details around that and the impact of the geology within Oregon, that lava that came from the Oregon-Idaho border. So in the meantime, just enjoy the Molalla River and all its beauty that's here. I encourage you to come up to the corridor and take a look at it for yourself. Witness the amazing geologic features that are here on the river, of which we've just filmed a few of. Thank you for watching this show.
Thank you for spending time with Welcome Molalla. We hope you enjoyed this episode and that you will come back for more and share with your friends.